Hey everybody, just wanted to welcome you to week 4, module 4 for ME 111 Structural Dynamics. So one of the key points I want to mention now is that your homework number 2 is assigned and is posted on Blackboard, and this will be due on the 28th by 11 p.m. Again, please reference the homework guidelines for details on formatting, grading, and submission. Your first homework assignment should have been graded by the TA. You should see your grades on Blackboard. If you have any questions related to his grading, please contact the TA directly. If you have any questions on how to submit or any of the content detail, please contact me either via email or on Blackboard or Teams. Quiz 4 has also been posted. This will be due on Friday the 25th by 4 p.m. Same basic format as before. This one's going to have 3 questions related to your reading materials from your textbook and from the lecture slides. So as we get into Module 4, we'll be getting into Chapter 4 material from our textbook. We'll be covering spring and damper elements in a mechanical system. So upon completion of this chapter, you should be able to model elements containing elasticity as ideal massless spring elements. You should be able to model elements containing damping as ideal massless damper elements. You should also be able to obtain equations of motion for a variety of systems having spring and damper elements. You should feel comfortable and be able to apply the energy methods to obtain the equations of motion. You should be able to obtain the free and forced response of a spring mass damper system. You should be able to utilize MATLAB to assist in the responsive analysis. So all along the way, if you need to plot things, you need to solve things, rather than do it by hand, you start feeling comfortable utilizing MATLAB to help you with this. And lastly, you should be able to use simple models of vehicle suspension to evaluate transient performance. We'll go over some simplified quarter vehicle methods within this chapter to show you some of these simplified examples for the vehicle suspensions. So you're going to break this module down into 3 different sections, 4.1, 4.2, and 4.3. The bulk of our time will be spent on 4.1 and 4.2. 4.3 is going to be a little bit of an overview and some special cases for the vehicle suspension. But for 4.1, what we're going to do is go into more detail with some of these spring elements, look at the modeling various types of mass spring systems, and take a look at different energy methods and how to use those to obtain equations of motion. For the second section, Module 4.2, we're going to get into some damping elements. We're going to also look at additional modeling examples. So we're going to try to add in the damping elements and other various things into our spring mass problems that we've looked at before in the previous section and make them a little bit more complicated. They may give us different information in the problem statement, ask us to solve for different things, and see how we apply all of those. And in the last section of this module, we're going to take a look at collisions and impulse response, associated equations, recall some things from previous texts and previous courses that will need to be applied to solve these problems. So in the last section here, this won't spend as much time with this. We're going to be looking at specialized cases here of vehicle suspension design, introduce some simplified models that we can utilize, do some review, and mainly in this review right here, what we're going to do is take a look at Laplace transform. I'm going to post up a couple videos as a refresher as you're going back through and need to apply these in some of my hand examples throughout this module as well. I've gone through and done some of the simplified Laplace transforms to hopefully give you guys a little refresher on how we can use those to solve some ODEs. So speaking of Laplace transform, I did include this as a PDF on Blackboard to this module as well, but I wanted to mention it here. There's many places that we can go back to a general table for Laplace transforms for various different functions that we're using. So we always want to look and see what are the general form that we're looking at here and what is our solution from the Laplace transform there. So I'll utilize a couple of these 2 in specific here, in particular here, as we go through a few of the example problems in this chapter.